When Lurik writes, he obviously wants it in this kind of in-between position, between pronation and supination, so he can write using his U-cuff. So that's the first problem we're trying to solve. How do we get Lurik's arm in between supination and pronation in a steady way? Second thing, his elbow can get weak sometimes when he writes because he has to hold up his arm. That takes elbow strength. There's some unsteadiness, it shakes, and that's tough for him. That's our second problem we're trying to solve. Third, we want to incorporate the fact that Lurik has shoulder movement, so we don't want to limit him in that regard. We want him to be able to use his shoulder movement that he has to write. So those are the three kind of design principles that we had in designing our writing tool that would help Lurik write with pencil and paper.
When we were exploring how we could solve these issues, we looked at what also was already out there and commercially viable. They were very bulky, kind of like over-designed contraptions that mounted to the wheelchair, or they completely immobilize the arm to where it's immobilizing the elbow and the shoulder. So we wanted to design something that would work with his body and work with his abilities, also while providing that support on his elbow.
Wow,
That's something.
all right, so this is GlideRite. So it's something that's
Could you hold
made.
it up real quick?
Yeah, oh yeah, so this is GlideRite, a prototype of it. It's something that's made to meet Lurik's needs specifically. It's molded to his arm, and it provides exactly those things that Paul was mentioning. It provides stability at the elbow, allows him to use his range of motion at his shoulder, and it doesn't interfere that much, so it allows his handwriting to still be a very personal thing. So this is what a U-cuff would kind of be like, and it allows him to write, writing stability. So,
Yeah. So when we started doing this prototype, we first went to Philly U. It was molded first with PVC that was cut in half, and then we used the Instamorph plastic that is molded off of your arm, and that's something that we envision being 3D printed in the future. The base is MDF, and then ball bearings are screwed into the bottom.
And just to clarify, the prototype we made was actually molded to Justin's arm using the Instamorph, so it would be actually molded to Lurik's arm, which is what gives him the stability that prevents him from pronating or supinating. I hit the temp button, sorry.
we went over this. We were safe. We used safety goggles. It was we went to Philly U and Jefferson, so it was a very collaborative experience, which was great. It was a lot of fun.
Next step, so we envision this as something that could be 3D printed at the top. Again, this needs further iteration. This has to go through the iterative process. We need Lurik's feedback. If this is something that does work for him, it's something that we have to kind of go back to the drawing board and prototype further. And we look forward to taking this to the next step. Thank you.
Thank you, Lurik.
Questions, comments?
I'm Molly.
What's up, Paige?
So we were trying to target very similar issue from the last group. We were trying to help Lurik write as well. And we were looking at a lot of the same issues, and we actually just came up with a name in the last few minutes. We created the arm skate. So Molly will walk us through some thought process.
So the first decision that we made was what kind of grip we wanted Lurik to be able to use. And at first we were thinking of using what's called the tripod grip, which was what we all use every day, and it hadn't occurred to us that that might not be feasible, but after talking to the OT students, we got an appreciation of just how challenging it is to use that grip at all. And so then we modified and decided to make a device that would allow Lurik to write using this cylindrical grip.
So just like the last group, we used this Instamorph that you started in some hot water, and then it was able to mold to Lurik's grip. So it doesn't fit me perfectly, but Lurik's hand was great. It fit perfectly in it, and the material is a little heavy, but it's great for a prototype. So ideally in the future, we'd be able to maybe make the coating just using this material and something light on the inside.
So we're going to talk about the functionality of the arm skate. So if everyone can see there, like, do you want to demo over here? But we wanted to kind of use Lurik's pre-existing arm braces that he already has to kind of use things that he's already comfortable with. So we tried to prototype that with this black one that Mike is wearing, and we've got straps around to hold his hand in this cylindrical grip. And the arm skate allows Mike to move back and forth, and Lurik, it would allow you to move back and forth on your pre-existing lap desk. that you use to write typically. So we're hoping that we may have to find a more low friction solution, but it works well just plastic to plastic.
And I just wanted to add to that we're trying to introduce the fewest amount of new accessories as possible. Lurik already has an arm brace and he has a lap desk that he likes to use. So the wrist brace is already there. We're basically only adding straps, and that's just a prototype. You can find something less bulky, and then adding this platform that we're going to talk about now.
So for the platform design, as you can see, it's at an angle like a wedge, so that he doesn't have to raise his wrist and fatigue it. So it's already raised for him, and he just has to move it like a CNC mill kind of thing. And I think that is easier for him because he has movement with his biceps, so that he can just move it forward and sideways. Moving forward, we are trying to attach his hand to this, maybe in a better way, maybe have silicone or something so that it doesn't move, rather than having a strap that maybe binds him to holding the skate to his arm rather than. And also we want to reduce straps on the pencil holder. We would also like it to be more of a clamp that can hold different sizes of pens and pencils so that he can keep changing them. Thank you.
Question?
And so we worked on a customized Wii remote for Lurik, and basically the need, we see a young 16-year-old man here who's very interested in sports, and we wanted to get him back to playing the games that he loves.
Here are some current products that are available on the market. McGee Rehab Center actually uses components of these products which are pulled from GIMP gear, and the individual pieces of it are really, really expensive, so the independence and the accessibility of the rehab kind of ends at the end of your visit. Many patients probably can't afford to bring these components home with them. And there's very limited customizability for the patient. The button system for this is just like one tab, and you can't really separate the buttons to put them in places that are optimized for how the patient would like to use them. And the one on the right there's a little bit of customizability in where you can put the Wii Remote, but it doesn't maximize the rehab potential for this device. And Lurik has a decent amount of range of motion in his arm, and we'd like to be able to build upon that and kind of strengthen that.
All right, so our solution has two components. The first is a wrist brace, which can go attached to the arm, and then you can hold the Wii Remote in two positions, either like this or like this with Velcro. The second component is a modified Wii Remote. So what we did here was we opened up the case, got down to the circuit board, and soldered two buttons onto the circuit board, one for A and one for B. The idea is we'd attach these until Lurik's headrest so he can turn his head, press the buttons, and play more involved games. Going forward, I'd like to give more button capability, so maybe including the home screen, some other features, maybe the joystick, and also coming up with some sort of housing in these headsets so we can press the buttons easily.
Great, yeah, I like that because it's so hard. Like Nintendo's never gonna make a customizable solution like that. So I think that's it. It's really novel to do the soldering.
I think in total we spent less than $50, including the Wii Remote, on this, and maybe 2 hours of work, which gets faster than more practice you are at soldering.
Did it actually work?
It works.
Oh,
yeah.
Okay, so
We prototyped it over winter break
Yeah, so you
with
can
my
see
friend.
that. If you press the
Can
buttons.
you press it? Can I see?
Well, I mean,
Oh, okay.
you can't tell which is,
Okay,
yeah.
cool.
And it seemed as though it was really simple to modify, which is
Yeah.
great.
We were able to find directions online that
Yeah.
helped us through it.
Was it through instructables?
It was slightly different. I think they wanted us to kind of change the
Yeah,
intent.
we tweaked
We tweaked
their
it.
design a little bit.
Okay.
Yeah, and we'd also like to think about ways that we could use the toggle system. So maybe that we also use head motions for the toggle, the joystick, that's what it's called.
And I think it also has great potential for whatever amount of movement or muscle control an individual has. So it doesn't necessarily need to be head controls,
Right.
but it can be modified to whatever level of ability they have. So that was really great.
Thank you, guys.
Hello everyone. For our group, I know a lot of people focus on writing, and that was one of our main components at first. But then we decided what the problem was is that Rick expressed to us that he was having a problem with changing the channels onto his TV remote. So we wanted something applicable to his daily life that would make it a lot easier for him to change the channels, watch his favorite TV shows at home, and something that could easily be accessible in his chair. So what we did, I'll just go take a picture.
So one solution we came up with would be a remote. This is a little bit bigger than life size, but being able to use his elbow for movement and having a guide, you'd be able to have it serve as an armrest, and using the like a guide underneath, it would be able to move from left to right, up and down, and using this small gesture, using your elbow, you'd be able to change the channel by moving just from left to right and up and down for volume. And we also thought of a pressurized button at the back where you could just push down with your elbow to activate a voice command, and then push down for longer to turn on and off the TV. And I'm thinking that the function would be like a joystick, so that way, as you're pushing forward, it would have enough resistance to bring it back to neutral. So if he's pressing up on volume, it would go back. So it would be a very easy gesture. Oh, something else I wanted to mention as well, I apologize, is we're using this hand grip for the palm, so that way he has a rest, and when he pushes forward, the entire controller will be moving with him, so that way his fingers will not bend or anything. It's just a very comfortable movement.
And the other idea that we were thinking about is like for him to be able to use his tools, like simple tools like a pen, pencil, or an Apple Pen, like the basic tools to write and draw for him. Like, he already has his lab desk, so we kind of had molded his hands and the negative space between his wrists on there. So because we also used the same material as the other guys just to mold. So he doesn't have to apply any pressure onto holding this. It just fits perfectly in his in between the negative space between his fingers here, between his palm here. So what he needs to do is, well, let's suppose this is a pencil. So he just has to grab this tool and then just rotate his wrist, which he's able to do until a particular angle. So that way we're using the thread mechanism that we use on bottle caps. That just rotate easily and open and close. So when you just rotate his wrist, he'll automatically lock, and then again rotate it back to unlock. So he can switch between pencil, pen, or whatever tool he wants to use.
And so the important thing is that all his utensils would have this attachment on it, and allowing him to keep all his utensils next to him and switch between the two objects.
Yep. So we just made a model and got it 3D printed, so that for custom tools like pen, those are cylindrical, and pencil, those are hexagonal. So we have this for a pen, and this one, the other one, is for a pencil. So it could be really easy for him to switch between different tasks. And going ahead, we also plan to getting his feedback and going again through to define the models particularly for his customer, for himself and also for people who have similar problems.
For the remote, how hard would it be to get that to a testable prototype?
A successful prototype?
Preferably, yeah. Yeah, you asked for that one.
I guess that wouldn't be too difficult. I guess we could do a 3D printed model and use foam materials.
I think you could probably just modify what you have and sort of hollow it out a little bit, and then wire it up so as to sort of hack an existing remote control, much the way the other group did with the gaming controller.
You see what we're doing now?
It's you learn a lot from having somebody actually try and use it. It's not really worth going to I think you've done a lot of work, and this is a great concept, but you'll learn enough having somebody use a prototype to actually change channels and volume that there'll be a redesign in it automatically.
Yes, there will definitely be iterations to that.
We'd love to, if you guys want to pursue that, I'd love to host that in our lab, that we have within Comcast to try it out if you're looking for a device to work with.
That would be great. I'd love to take the opportunity.
I think the writing tool that you presented also has potential, that the piece that's on the pens has potential for adaptation for a mouth stick. So if somebody doesn't have the use of their hand or their arm, that it could be adapted that way with a nice docking system. So that was great too.
Yeah. Yeah, I like that adaptable system because I could see a whole like product line along that
We can
with
use
pens
it.
and utensils and that you could just swap in and out.
Right.
Did you guys see anything else already in market similar to that concept?
No, we did not.
Well, we knew we had the handcuff thing, and we kind of wanted to see a modification off of that, but, there were a couple things out there, like where you can put your fingers in, but nothing that had like that lock and key type motion to it. So that's what we were looking for, things that you could easily access multiple tools. So that was our idea for that.
Yeah, that's a really good point, because most people who require that or who have that level of disability would not be, they need somebody to change the tool in the hand. So this gives them the flexibility to do it on their own. All right.
Thank you.
Thank you.
Hi everyone. So the product our group came up with is called TinaDex, and it's a combination of using TinaDesis as well as dexterity. That's kind of how we came up with the name. So we met with Larique, we talked similar to other groups about what his greatest goals were and concerns were, and he expressed that he wanted to get back to school and that he wanted to be able to take his own notes. And we entertained the idea of him using a tablet or other devices that are out there, and he said that he was kind of old school and the pen and paper was his preference. So with that, we started further talking with him, and we were able to discover that he has some ability to use TinaDesis, which basically means that when he relaxes his arm and lets his left arm fall back, he has naturally a grip that starts to form with his fingers that he doesn't require active motion to do. So with that, we decided to look at other products that were out there and find a way that we could augment his ability to do that so that he could have greater grip strength. So the first thing you see here is a TinaDesis brace, which is already out on the market, but after talking with other people that are in the OT field, they let us know that it hasn't really evolved much. It's kind of clunky and bulky and not that sleek. And then through another project we did here at the Comcast lab with the Enable Foundation, we started to get some ideas with the tension system that arm uses, which it employs wrist grip, which then causes the fingers to contract. So we got together and tried to figure out a way to where we could almost have a reverse mechanism of this. So where with the TinaDesis, he could then get the contraction coming from his fingers. And then Matt's going to talk about a little bit more about the
Absolutely. So the other inspiration was the Flyknit sneakers and the knitted tension wires that are already inherent in those sneakers. So we figured, why not combine the Enable hand with that tension system, reverse it, as well as incorporate that into a glove. So that is what we did. And so the first picture there is just a really, really rough prototype. Is this possible to do with that motion? Can you reverse engineer flexion based on extension? And we showed that you could do that. And then we have a glove, the first generation glove, which actually Lexi has, and we can pass this around, that shows that once you have a wrist anchor, and you have finger anchors, you can create flexion and augment that grip strength that Larique is looking for to grip a pencil. And then we have a second generation, which I'm actually wearing, and hopefully will continue to improve upon. Well, I don't have a pen yet, sorry. We're gonna put it on Larique's wrist, and hopefully we can have him play around with it a little bit later. But yeah, we hope to improve in the future, having a self-adjustable anchor, and as well as incorporating the tension wires more into the glove.
So explain how we built it. So the main goal is to allow him to basically be able to grab a pencil and write with it. So using like the tension can allow him to have an enhanced grip on the pencil when he's trying to write in class. So the main goal is to try and make this a little bit like more open, so it's like a little bit more like airy, because especially during the summertime it might be a little bit warm since this is a full glove. But we did connect kind of like loops in between that connect to all of the like essential joints where you would need a little bit of tension, so that when he flexes back his wrist, it literally puts his fingers into a locked position where he can successfully grab a pen and have you know, enough strength to be able to write with. So that's basically it.
Yeah, that's us.
You guys snowboard at all?
I do not.
No.
So it's for the advanced like snowboard boots, they have the adjustable kind of wire technology.
And the great thing is that's a licensable technology called BOA, and I think they even sell a developer kit for that. So they'll license that to anybody who finds an interesting new use for it.
Cool. Yeah, that's basically like next steps is we want to try to find a way that with each user they'd be able to customize to their preference and to like how they want to handle it, to where they could adjust each finger, and we could continue to add. We did the first 3 fingers, but we could continue to add additional fingers that could come into play as well. But we wanted to focus on this first.
You plan to pursue this?
I would like to.
Yeah, I would like to see some of the knitting and weaving technologies that you guys have up at Philly U, that we could really incorporate these into the structure of the glove as opposed to just being external.
Yeah, because right now you can't really. It would probably fall apart with what we have just because it's all external. But if we could somehow get it into the glove, that would be great.
Yeah, absolutely. I'd love to put you in touch with some people who could help you talk that through.
Great, thank you.
Brilliant. Hi everyone, I'm Adesola.
And I'm Michaela. Our third team member, Kat, is unfortunately delayed, so we're going to present on her behalf today.
So basically our problem statement and our solution is, after we met with Larique a couple of weeks ago, he expressed that he wanted to be able to write when he gets back to school and wanted to give him back that ability. And wanted to create a device that was efficient for him to do that, as well as something that was also comfortable. So our initial idea was to basically get a ball mouse, which will allow for like easy movement and less friction for him. And we're going to also use a wrist brace. And in our last session, we tested that with him, and we realized that using a brace was going to limit the range of motion that he already had. Also, with the mouse, we realized that his fingers were a little longer than we were anticipating, so we decided to augment that, and Michaela's going to talk about that with our product.
So our product is called the Gumby, for if anyone knows Gumby. Thank you, Lexi, for the name. We have taken the original ball mouse, so it's a caster, allows it to glide, and built it up with Model Magic, which is a very lightweight modeling foam. We realized early on it would be very important for Larique to be able to lift it up easily and move it. We have attached it to, so it would be attached to his hand with elastic straps. These are removable, washable. And then the pencil or pen, whatever writing utensil he chooses, is just held in here. This design to hold the pen is not kind of permanent. We're not married to it, but it flicks in and out. So it can be changed. This is built up, will support his hands, but it doesn't rub on the ground, so the mouse, or on the paper, whatever writing surface he's using, so it still glides nicely. We also have a small elbow support for him, but we're not sure kind of with his chair what's going to be best, so that's something that definitely needs to be looked at further in future iterations. This is very much a rough prototype. We need feedback from Larique. This is not molded to his hand. We don't know how loose it needs to be. We don't know if he's going to be able to write with this. We'd also, in further iterations, like to include an eraser attachment, so he doesn't have to, say he wants to switch from a pen to a pencil, that's fine. But we'd like to have pencil and then say an eraser here that he could use. He doesn't have to swap the pencil out every time he wants to erase something. We also need a more durable solution for elbow support. As I said, that needs to be incorporated once we know kind of what works for him, how elevated it needs to be. And also, this is Model Magic. It's basically a kid's toy. It's great for prototyping, but I'm not sure it's going to be super durable for use. So those are the things that we need to address in the future. But yeah. Questions? All right, thanks.
Okay, we're gonna get started. Hi, my name is Jared Bowden.
I'm Colleen York, and I'm yes me.
Okay, great. So we are Vocability. Into it. So today there are tons of technologies that people utilize. And these technologies are really, really great at engaging all of our senses. However, a lot of times they require all of our senses, and that can be such a problem for people with limited abilities. So, we think that at Vocability, we think that the most powerful muscle that Larique, you have, and that a lot of people have, is their voice. And there's a lot of voice-activated software out there right now, including Alexa. And however, this still kind of requires some additional senses. It requires some, using of muscles. It requires some sight. It requires a lot of things, not just voice. So we hope to bridge that gap. Our first product is a headset that can link with an Echo Dot that can actually be put into this headset. And it has speakers inside the headset that we can actually use so that you can take Echo Dot and voice-activated software with you. And with that, I'm going to turn it over to Colleen so she can demo some of it and get to the good stuff.
Let's try out some functions. So Alexa's got a lot of functions, but she's listening to me. Alexa, send a text message to Vaughn. Alexa, I'm sorry. Tell AT&T. Oh, she's got it. Sorry. Turn it up. Alexa, tell AT&T to text Vaughn.
Your contact list does not include Vaughn.
No, with a V. Okay, how about text Rob?
Please try again. Then the contact name.
Text Rob.
What would you like to say to Rob?
Hey, look, it's working.
Sending a text to Rob. Hey, look, it's working.
Sure enough, you should get.
I got it.
Oh. Perfect. So let's try some other functions. I guess the one function that really inspired us was you always had your headphones strapped to your chair, but it's obviously like a challenge to get that on whenever you want. So with the headset, you can have the built-in speakers. But what's your favorite artist?
I got a lot.
Something appropriate, please.
Well, then I won't answer that question.
How about we do Chris Brown? Do another new song. Alexa, play Chris Brown.
Playing Chris Brown from Spotify.
Okay. We have one more function for you.
Okay, we're gonna get the lights.
Alexa, turn on the lights.
Okay.
is like our first prototype, but there are a lot more capabilities and functions that we can add just by using your voice. So eventually we can add better speakers. They can be Bluetooth speakers. Right now they're plugged in. We can shape the memory foam to your head to fit whatever's best. Right now it just straps onto your wheelchair. And then also more long-term goals would be to connect more lights, more functions in your house. It can be anything, your TV, whatever. And then also one of the reasons we chose the Echo Dot is because it's very easy to develop, they call them skills. It's basically an app for your Echo Dot. So you can add a bunch of custom apps that work for you you in school, work for you at home, work for you, you know, when you want to know your sports updates or whatnot. So we hope you like it.
Yeah. Any questions?
Yeah, this is amazing because when I was working clinically, and we used to call this environmental control units, they were about 1.5 feet wide and 1.5 feet long. They cost thousands of dollars, and it was never voice activated. So to see how technology has advanced in a relatively short amount of time is amazing, and how much control one could have portably. It doesn't have to be only in the home.
Absolutely.
Yeah. And I think that technology is still not designed for the people who could use it most. So really tweaking that, I think, is really important moving forward.
Yeah.
So do you guys plan to do anything more with the prototype? How to evolve it? Or?
Yeah, I think we found a lot of ideas. I mean, really, as Colleen was mentioning, there are kind of hardware implications. So we could make more headrests that are designed for certain chairs and things like that. We can also expand in a lot of different directions. We can also improve the software by building apps that are specific to people and their varying abilities.
We can basically make his home life evolve into a smart life so that things are much easier for you, Lurik.
Yeah, what if Lurik went to an OT and OT had someone code them a specific app to be used with this? It'd be incredible.
Yeah, and it has applicability at school, at work, in the home, and older products were just in the home.
Right. So with the Echo Dot, you can actually have a textbook read to him. So that's
Yes. Yeah.
And then did you guys hook up? You sewed functional speakers into that thing, didn't you?
Yeah.
I wasn't playing just now, right? That was the.
No. It's like personalized just so that you can hear it when you strap it onto your chair.
Right.
Yeah, so
but we can test it out.
Yeah, if he's out and about, it's not everyone that's hearing Chris Brown. It's just him.
Yeah, so we actually have like a pouch where the Echo Dot can go fit in here, and when he speaks to it, there are speakers attached inside that only he can hear. So, you know.
Yeah, and we did test it out so that you can, like Alexa can hear you when it's still like strapped on your chair and your head's in front of it. We can get you to try it out. Yeah.
Any other questions?
I like how you use. I just bought one of these yesterday because of the Black Monday sale. It was like $30, but you know, and kind of just it's such a hacking existing technology because you don't have to reinvent the wheel, but you can find like different kind of use cases for existing technology. So that's great.
Does it have the ability to audio record? So if I was at school and I wanted to audio tape or record a lecture, can you do that?
It actually it recorded everything that I said.
Oh, okay.
And so it's like already on my phone, but we can play it back. Let's see. Here.
Hook up the
This is when
cushion.
I was trying to. So that was my voice saying like any command you say, but all of the recorded audio goes to your phone and saved. So it's pretty cool.
Did you guys ever check out any bone conduction solutions or anything? I know you mentioned the difficulty, Lori, that you've got with taking headphones on and off and things.
Yeah.
With the bone conduction solution, you can free up the ear canal and stuff.
Yeah. We actually thought about that, but I guess for the first prototype, it's just like, you know, way more inexpensive. We just got some cheap speakers and then planted them onto a pillow. but
really cool.
bone conduction, it's actually a great idea.
Yeah, definitely. All right, great. Thank you guys so much.